In this video we're going to consider how to find the area of a segment. So that's the shaded region in this diagram. So if we think of this as a compound shape, then we can think of it as the area of a sector subtract the area of a triangle. And these are both things that have been covered in previous videos. So the area of the sector is given by half r squared theta, and the area of the triangle is given by half AB sine C. But in this particular instance, A and B are both going to be the radius of a circle. So it's half r squared theta minus half r squared sine of theta. And often we can write this in a factorised form. So it's half r squared of theta minus sine theta. So let's work it out. So the area in this case is going to be half of 4 squared multiplied by 0.3 minus sine of 0.3. And because I'm using sine of the angle, I need to make sure that I've got it in radians mode. So to put it in radians mode, I'm going to do shift, set up, and then one of these options here, which on my calculator is option number 4, has rad. And now on the top of the screen here, the D has disappeared and the R has appeared next to it, and that reminds me it's in radians mode. So now I can type it in. So half multiplied by 4 squared multiplied by 0.3 minus sine of 0.3. And I get there a very small area here of 0.036, and that will be centimetres squared. Now this second question, I've got a segment here, but I don't have the radius or the angle, so I'm going to have to work those out. So let's just consider the angle first of all. I'm told that this reflex angle is 7 pi over 5, and I know that the full turn is 2 pi radians. So from that information I can work out that this is actually 3 pi over 5 degrees. So how am I then going to calculate the radius? Well, this is an isosceles triangle, because this length is a radius and this length is a radius. So what I can do is split this down the middle to form a right angled triangle. Now, an alternative to this would be to use the cosine rule, but when we can use right angled triangles, it's simpler. So there's my right angled triangle. I knew that the whole length across here was 7, so therefore this length must be 3.5. This angle here would be half of my angle there, so that would be 3 pi over 10. And it's this length which I wish to find, which I'm going to call length x. So then, using trigonometry, if this is the angle concerned, I've got the opposite side and I wish to find the hypotenuse. So that's going to be using sine. So sine of 3 pi over 10 equals opposite divided by hypotenuse. So x is equal to 3.5 divided by sine of 3 pi over 10. So I'm going to evaluate that on the calculator now. And that's 4.33. But because I'm going to use this value in a moment, I'm going to store it in memory A using the store function of the calculator, which is shift and then STO, and then select the relevant memory. So when I now find my area, I can do half. I put it in memory A, so it's half of A squared multiplied by 3 pi over 5 minus sine of 3 pi over 5, and I can just type that into my calculator now. And I get there an area of 8.74 centimetres squared to 3 significant figures.